Hello students, welcome you all in the lecture series on numerical interpolation. In first two lectures, we have seen about the basics which we need to learn numerical interpolation. In first two lectures, we have seen the functions, value of functions, how to find value of functions at the set of given values of x which are equidistant. Related to equidistant values, the increment h, generation of set of points, and the operator which we need, first operator, forward difference operator, its definition, and how to construct the table for forward difference. Also, we have seen the orders of forward difference operators. Based on these basics, now in this lecture, we will solve some examples on forward difference operator. In this lecture, we will see how we can find the difference table or how we can construct the difference table when we have given the set of points, and how many differences will exist when we have given the set of values of x. That is, if you are given n set of values, then how many orders, up to how many orders we can find the forward differences of that table. So let us see now the examples of based on forward difference operator. Look at this example. This is question 40 from the question bank. The question is, if h equals to 1, then evaluate delta square f of 3. Now you are aware of the function f of x. So if here x equals to 3 and delta square means second order forward difference of the function f of x at x equals to 3. You have given value of h also here. So like it's in the answer, let us see. So as given, x equals to 3 and h equals to 1. Now we will use here the definition of forward difference. So we have seen, and you always remember this basic definition. Only remember this definition so that you can find all the differences of all forward differences here. What is the basic definition? Delta fx equal to f of x plus h minus fx here. Okay. We are using only this definition to find delta square f of 3. As we have seen yesterday, that is in lecture 1. What is delta square? Delta square is repetition of delta. So we are operating 2 times this delta on the function f of 3. Use the definition. So delta f of 3 means just substitute x equals to 3 in this formula. Wherever there is x, we will put x equals to 3 and h equals to 1. So using this, now we will get it as f of 3 plus 1. F of x plus h means f of 3 plus 1 minus f of 3. What is it? F of 4 minus f of 3. So again applying delta on f of 4 and f of 3 here. So that is, we are solving this bracket. It is not multiplication. We are operating this delta on f of 4 and f of 3. So the first term is delta f of 4 minus, this sign will be as it is, delta f of 3. Again use the definition. So here x equal to 4 now. and h is already given as 1. So substituting x equal to 4 in this formula, what we get? F of x plus h means what? F of 4 plus 1 minus f of x means f of 4. This is what? Value of delta f of 4. Now for delta f of 3, we have already calculated value here as f of 4 minus f of 3, but still we are writing it again. So this value is f of 3 plus 1 minus f of 3. Simplifying, we get f of 4 plus 1 means f of 5 minus f of 4. Then f of 3 plus 1 means f of 4 and minus f of 3. Solving this, what we get? F of 5, this f of 5 minus f of 4 as it is. This term is as it is. So this first bracket term is as it is. Now we are multiplying by this minus to this whole bracket. So first term will be minus f of 4. Minus into f of 4 will be minus f of 4. Now multiplication of this minus with this minus will be plus. So here we have plus sign here. So what is it? Plus f of 3. So just adding this and subtracting whatever it may be as given in the example as we have obtained. So f of 5 is the term as it is. Now f of 4 is repeated 2 times. Here minus f of 4 and here also minus f of 4. So minus f of 4 minus f of 4 means 2 times it is repeating. So it is minus 2 f of 4 plus f of 3. So final value is what? F of 5 minus 2 f of 4 plus f of 3. So value of delta square f of 3 is f of 5 minus 2 f of 4 plus f of 3. So if we know the basic formula to obtain the forward difference, we can obtain any order forward difference using this basic definition. And here you have to take care of this powers of this forward difference, as this is not multiplication, it is repetition. So if it is repeated 2 times, you apply 2 times delta on the function. If it is delta cube, means you have to apply 3 times on the functions and so on. So in this way, we can obtain value of order of any forward difference at any value of x if h is given. So h must be given here, then only we can find it. Go to the next example now here. Next example is, example is based on the equidistant values of x and the corresponding values of the function. So next example is, construct the table for first 3 values. Now here first 3 values, and here you have given, means if you read completely the example, let us read it first. So for first 3 values of the function fx equal to x cube plus 2x minus 1 at x with equal increment in x by h equals to 2. Take initial value of x equal to 2. So here you have given equal increment h equal to 2. Means what? We have to obtain the equidistant values of x. So that's why here when first 3 values of the function fx means what? You have to find values of the function till n equals to 2. Means first you obtain values of x till n equals to 2, because in equidistant values of x we always count it from x0. So what will be your first value? First value is x0, second will be x1 and third will be x2. Means what? N equals to 2. So in this way we will construct the table having the values x0, x1, x2. And the corresponding value of the function is y0, y1, y2 respectively. As you people have given here the formula, immediately we can calculate value of the function. So construct the table in this manner. Now initial value of x is 2, that is x0 equal to 2. So first value is x0 equal to 2. Now at x0 equal to 2, corresponding value is y0. How to obtain it? You people have given this formula, x cube plus 2x minus 1. So substitute x equals to 2 in this formula. We will get value of y0. So here is the value. It is 2 cube plus 2 into 2 minus 1, which is equal to 11. This is value of y0. Secondly, x1. How to obtain x1? Adding h to x0. So it is x0 plus h. x0 is 2 and h is equals to 2 we have given in the example here. So 2 plus 2 equal to 4. So at now x1 equal to 4. Obtain value of y1. Substitute x1 equal to 4 in the formula. But we get 4 cube plus 2 into 4 minus 1. And the value is 71. Here the value is 71. Now obtain x2. How to obtain x2? Add h to x1. So what is it? x1 equal to 4, h equals to 2. So 4 plus 2 equal to 6. Substituting 6 in the formula of the function, what we get? 6 cube plus 2 into 6 minus 1 equal to 227. So in this way we can construct a table of equidistant values of x and its corresponding values of the function y if we have given initial value, here increment and formula of the function. Let us go to the next example. We will take the next example on forward difference table. We will do practice of it. Let us read this question. Construct the following forward difference table and find values of delta square y0, delta y20, this is delta square y10, then delta y20, delta cube y15, delta raised to 5 y10. Now here if we observe, till now we used the notation that delta square y1, delta square y2, or delta raised to 5 y0 or delta raised to 4 y, means suffices are 0, 1, 2, 3 type. But here the suffices what we see is 10, 20, 15, 10. But in the data you don't have given that much values. You have given only 5 values. 1, 2, 3, 4, 5. We'll see later on that what are these values. But I can see here 10 as well as 15. Here delta cube 15, 15 is there. Delta square 10, 10 is there. Delta y20, 20 is there. So sometimes instead of giving the position, now x0, x1, x2, x3, these are the position, or y0, y1, y2, y3, these are the position of that corresponding value. So instead of giving the positions, they directly give here these values of x0, right? So here delta square y10. So let us here see here. So delta square y10 means delta square y at x equal to 10, isn't it? Here 10 equal to x0, because when we construct the forward difference table, this 10 will be our initial value and we will give the name to this as x0. Now again one thing, if we observe here, first we have to check to construct the forward difference. First we have to check whether the values of x are equidistant or not. So as I explained in my lecture 2, how to check whether these are equally spaced or not? Just consider two consecutive values of x. So let us suppose here first value is 10 and next value is 15. What is the subtraction? 5. And it should be there for the next values also. Means the difference between two consecutive terms for next values of x must also 5. So let us see. Next value is 15. Next value is 20. And what is the difference? 15 and 25. It is 5 here. Then if you consider next two consecutive values, then it is 20. Next is 25. So again the difference is 5. Again next two consecutive values. This value is 25 and 30. Again the difference is 5. So here we can say that h equals to 5. So here h equals to 5. Means these values of x are equidistant and we can construct a forward difference table. And now we will give names to these values as x0 equal to 10, x1 equal to 15, x2 equal to 20, x3 equal to 25 and x4 equal to 30. So here as per the example n equals to 4 here, right? So delta square y10. Now let us see what we want to find here. So delta square y10 means what? We have to find delta square y0 because 10 is our x0 and y0 means value of the y at x equals to 10. So here it is delta square y0. Similarly, delta y20 means delta y at x equals to 20. But what is the position of x equal to 20? x2. Look at here. This is x1, this is x2 and this is this is x0, this is x1, this is x2. So 20 equal to x2. That is we have to find delta y2. Similarly, delta cube y15 means delta cube y at x equals to 15. And now what is position of 15? That is x1. That is we want to find delta cube y1. Now next value is delta raised to 5 y10 which we want to find here. So delta raised to 5 y10 means delta raised to 5 y at x equals to 10. But means what? Delta raised to 5 y0. So let us construct the table now. See, when you want to construct the table, you please first construct. Now here n equals to 4 means 4 differences will exist. So according to that, you construct the columns and also give the name to that values position according to their positions here. So here 10, x first value is 10. So x0 equal to 10, then next x1 equal to 15, then next x2 equal to 20, then next x3 equal to 25, look at here, then x4 equal to 30. Let me highlight these values. Okay. So when you construct a table, first thing which you do is give the name to that values, that is according to their positions. Now similarly we have given values of y. These are values of y. So first value at x0 equal to 10 is y0. Give its name y0. This we are giving their positions so that we can use formulas directly. In our lecture 2 we have seen the formula table. So according to that we can immediately construct this forward difference table. Then at x1 this value is y1, then let it be y2, then let it be y3, then next is y4. Okay, now let us calculate this delta y0. So what is it? This delta y0 is y1 minus y0. So directly we will substitute the value here. 21 minus 51, 21.51 minus 19.97. So what is the answer? The answer is 1.54. This is your delta y0. So first order difference we got here of y0. Next value, how to obtain it? It is y2 minus y1. Now in our lecture 2 we have seen the table. So you please remember that table and the technique of that subtract the value whose forward difference we want to find from its successor value, that is succeeding value, this next value. So here we are considering 22.47 minus 21.51 and the answer is 0.96. So here we have this difference delta y1. Similarly, now we will find delta y2 is y3 minus y2. So what is y3? Y3 is 23.52 minus 22.47 and the answer is 1.05. So here we got delta y2. Next we'll find delta y3, that is y4 minus y3. So obtain it. So this is equal to 24.65. This is actual demonstration that how we calculate practically the values of forward differences. So in this way, you should construct the forward difference table and get the values. As this forward difference table has, we are using this table to obtain value of x at certain value given x using Newton's forward interpolation formula. So here we have all the first order forward differences. Now we go to the next forward order differences. So now we will use this column of first order forward difference to calculate the second order forward difference. So how it is? So this delta square y0 is delta y1 minus delta y0. So directly you pick up the values from this table because we have already calculated it. So it is 0.96 minus 1.54. So again I am telling this is actual demonstration what we are doing to obtain practically how we can obtain the forward difference table. In your notebook you write in this manner only. So now delta square y1 means delta y2 minus delta y1. So this is equal to 1.05 minus 0.96. What is the value? It is 0.09. So in this way we have here delta square y1. Similarly, delta square y2 is 1.24 minus 1.05 equal to 0.11. So we have done it. We got it. Now again, now look at here. Initially n equals to 4. There are 3 forward differences. N equals to 3. N equals to 2 second order forward differences. N equal to 1. 2 forward differences here or third order forward differences, and last one is delta raised to 4. So let us calculate here this next. Directly from this column we will pick up this value. So it is delta square y1 minus delta square y0. So it is 0.09 minus, now this value is minus, so I will put it in the bracket. So minus 0.58, and this is equal to, what is it? This is equal to 0.09 plus 0.58, and what's the value? 0.67. 0.67, right? So in this way we got this third order forward difference. Okay. Now for this delta cube y1, we will have delta square y2 minus delta square y1. This is equals to 0.11 minus 0.09. So which is equal to 0.02. So we have got this difference. Now the last one here equal to 0.02 minus 0.67. So what is it? Minus 0.65. So in this way you can complete the table using the formula table. So this is a practical demonstration which I have shown to you here, that how we construct the forward difference table. You have to do a lot practice for this forward difference table, how to construct it, because this has a major role in the Newton's interpolation formula. So here are some examples for the practice. See this. So you have given in first table 1, 2, 3, 4, 5, 6, that is n equals to 5, and in the second table 1, 2, 3, 4, 5, 6. So again here n equals to 5. So use the formula table for this and construct the forward difference table. In our next lecture we will see the Newton's interpolation formula for forward difference and how we solve the example using this forward difference table. Oh, thank you.